This video is on the properties of limits. So, before we write down the properties, we have to write down the assumptions that we're making. So, we're going to say, suppose that C is a constant. And by constant, I just mean some sort of number. So, suppose C is a constant and two limits can be evaluated as follows. The limit as x approaches a of the function f of x equals L, and the limit as x approaches that same value a of another function g of x equals k. Then, if those things are true, then we have these different properties of limits that will also be true. So the first property is about scalar multiplication. And a scalar multiple says that if you have the limit as x approaches a, and you've got some function, so some multiple being multiplied by a function, maybe the function has a 2 in front of it or something, then that is exactly the same as if you take c and you multiply it by the limit of the original function. Or we could think of this as if you have that multiple there, we're going to do c multiplied by L, whatever that limit happened to be. So if your limit was 5 for this original function, and then you take that function, you put a c in front of it, then it would just be c multiplied by 5 is your answer. You don't have to calculate the limit all over again. So these are basically, they're just saving you some time. The next is going to be sum or difference. So if you have the limit as x approaches a of f of x plus or minus g of x, so it doesn't really matter if you're adding these or subtracting these, that's exactly the same. You could find the limit of both of the two things being added together, and that's the same as what you would get if you had already found the limit of those two pieces separately. I meant to write f of x first. I was talking and I got confused. Forgot where it was. So plus or minus, whichever one you happen to be doing. And so that's the same as saying it could be L plus or minus K. Next, we have the product. So if you have the limit as x approaches a of f of x being multiplied by g of x, that's exactly the same as if you had the limit as x approaches a of f of x, and you were multiplying it by the limit as x approaches a of g of x. So that's like you're taking your L and you're multiplying it by your k value. Next is the quotient. So if we have the limit as x approaches a and we're dividing two functions, f of x divided by g of x, then that's exactly the same as taking the limit of as x approaches a of f of x and dividing it by the limit as x approaches a of g of x, which it would be the same as doing L divided by k. And then the last one is the power property. And this says that the limit as x approaches a of some function that has been raised to an exponent of n is the same as if you took the limit as x approaches a of that function and took that whole thing and raised it to the n power. So in this case, we would say that would be L to the n power.